Our Sun, that vital source of energy for life on Earth, is a star. A totally unexceptional star, just like billions of others that we can find throughout the galaxy.
A star is nothing but a sphere of glowing gas. It forms out of a compressed cloud of gas and releases energy steadily throughout its life because a continual chain of nuclear reactions takes place in its core. Most stars combine hydrogen atoms to form helium through the process called nuclear fusion, the same process that powers a devastating hydrogen bomb. In fact, stars are nuclear factories that convert lighter elements into heavier elements in a series of fusion reactions. They will keep glowing until they run out of fuel. And that's it, a star's life, a quiet beginning and a steady progress to a sometimes violent end. But how can we be certain of this picture when an individual star like the Sun outlives humans by a factor of a few hundred million?
To investigate the life cycle of a particular organism on Earth, we don't have to track an individual specimen's entire life. Instead, we can observe many of the organisms at once. This will show us all the different phases of its life cycle. For example, each stage of a person's life is a snapshot of the human experience. And so it is with stars.
Stars live and die over millions or even billions of years. Even the most reckless stars live for at least 1 million years, longer than the entire history of humankind. And that's why it's extremely difficult to track age-related changes in individual stars. To learn more about them, we must study different stars at every stage of life, and so piece together the entire cycle from birth to death. Hubble's vivid images have documented the tumultuous birth of stars and delivered many astonishing images in colourful detail.
The birth of stars in neighbouring stellar maternity wards can be used as a time machine to replay the events that created our solar system. Hubble has often had to work hard for this information, because these important clues about our genesis lie hidden behind the veil of gently glowing, dust-laden molecular clouds where stars are formed. Right now, there are stars forming everywhere in the universe. Enormous glowing pillars of dusty hydrogen gas stand sentinel over their cradles, basking in the light of nearby, newly formed stars.
Hubble's ability to observe infrared light enables it to penetrate the dust and gas and reveal the newly born stars as never before. One of the most exciting of Hubble's many discoveries was the observation of dust disks surrounding some newborn stars buried deep inside the Orion Nebula. Here we are actually seeing the creation of new solar systems where planets will eventually form, just as they did in our own solar system 4.5 billion years ago. In the first stages of their lives, stars can stock up on gas from their original birth cloud. Material falling onto the star creates bubbles, or even jets, as it's heated and blasted out along a path that follows the star's rotation axis, a bit like the axis through a wheel.
Often many stars are born from the same cloud of gas and dust. Some may stay together through their whole lifetime, keeping step as they evolve, like childhood friends that you keep for life. The stars in a cluster will all have the same age, but will have a range of different masses, and this means that very different destinies await them. Human existence is the mere blink of an eye compared with the life of a star. So the direct observation of a transition between different stages of a star's life can only come about by lucky chance. In 15 highly productive years, Hubble has allowed us to observe some stars aging in real time. The telescope has produced startling movies that allow us to witness how some of them do modify their appearance over this minute span of astronomical time. The stars containing the most mass end their lives cataclysmically, destroying themselves in titanic stellar explosions known as supernovae. For a few glorious months, each becomes one of the brightest objects in the entire universe, outshining all the other stars in its parent galaxy. Since its launch in 1990, Hubble has watched the drama unfold in supernova 1987A, the nearest exploding star in modern times. The telescope has been monitoring a ring of gas surrounding the supernova blast. Hubble has observed the appearance of bright spots along the ring, like gemstones on a necklace. These cosmic pearls are now being lit by supersonic shocks unleashed during the explosion of the star.
The ruins of an exploding star can hide a powerful engine. Hubble has probed the mysterious heart of the Crab Nebula, the tattered remains of an exploding star, vividly described by Chinese astronomers in 1054, and has revealed its dynamic center. The innermost region of this nebula harbors a special type of star, a pulsar. Like a beacon, this star rotates, emitting energy and light in a beam, and it powers the vast nebula of dust and gas surrounding it. However, not all stars end their lives so violently. Sun-like stars cool down once they run out of hydrogen. The center collapses in on itself and the heavier elements are burnt, causing the outer layers to expand and leak slowly into space. At this stage in a star's life, it's called a red giant. Our Sun will become a red giant in a few billion years. At that time, it will expand so much that it will swallow Mercury, Venus, and our planet too. But these stars are not finished quite yet. They can still become something quite extraordinary.
Just before they breathe their last breath, stars like our Sun go out in a final blaze of glory. In its final stages of nuclear fusion, stellar winds blow from the star, causing the red giant to swell to an enormous size. At the heart of this expansion, the exposed heart of the star floods the gaseous envelope with powerful ultraviolet light, making it glow. Because to early telescopic astronomers these amazing constructions looked a bit like the newly discovered planet Uranus, they became known as planetary nebulae. Hubble's keen perception shows that planetary nebulae are like butterflies. No two are alike. Hubble's dazzling collection of planetary nebulae show surprisingly intricate glowing patterns. Pinwheels, swirling jets, elegant goblet shapes, barrel shapes, or even rocket engine exhausts. From its unique position high above the distorting atmosphere, Hubble is the only telescope that can observe the swollen outer envelope of these dying stars in full detail. Here we flip back and forth between Hubble images from 1994 and 2002. One of the greatest mysteries in modern astrophysics is how a simple spherical gas ball such as our Sun can give rise to these intricate structures. For some planetary nebulae, it is as if a cosmic garden sprinkler created the jets that stream out in opposite directions. Or could these amazing patterns possibly be sculpted by the magnetic field of a companion star that funnels the emitted gas into a jet? Whatever their cause, in only 10,000 years, these fleeting cosmic flowers disperse in space. Just as real flowers fertilize their surroundings as they decompose, the chemical elements produced inside the star during its life are dispersed by the planetary nebula to nourish the space around it, providing the raw material for new generations of stars, planets, and possibly even life. Because they disappear so quickly on a cosmic timescale, there are never more than about 15,000 planetary nebulae at any one time in our Milky Way. A more lasting monument to the dead star is the tiny heart it leaves behind. Known as a white dwarf, each of these exceptionally dense Earth-sized stars are fated to spend the rest of eternity gradually leaking their residual heat into space, until eventually, in many billions of years, they approach the frigid -270 degrees centigrade of space.